So it's a pleasure to introduce Marie-Josephe today from Bangor University. She did a PhD in Montreal on Aphasia and basic genetics, and then she went on to do a postdoc with Alfonso Caramatza. She worked closely with Brenda Rapp looking at phasic disorders, particularly acquired dyslexia and reading disorders, or acquired dyslexia and acquired dysgraphia, so spelling disorders. After a postdoc, she took a lectureship position in Grenoble and then moved to Bangor University 15 years ago, was it? So she's been there quite a while. And she's now got her own lab, the bilingual aphasia lab, and she's looking at spelling deficits in patients with language disorders and whether they have the same deficit in both Welsh and English. And she's also looking to see if treating the patients in one language will generalise to the other language. So as well as looking at patients with language disorders, she's also interested in rehabilitation as well. So, and today she's going to be talking about the organisation of lexical knowledge in the bilingual brain. So I'm over to MJ.
Thank you, Dan. Well, I'm very pleased to be here with you today. It's my first time at Liverpool John Moores University. And also, Dan forgot to say that he's been working in my lab for 3 years. And he's actually coming straight from my lab to here, so it's particularly nice also for me to see, how he is, to have a look at his new surroundings and so on, and check what he's doing when he's not working for me anymore. So thank you very much for the kind introduction. I do work on all the things that you said, except I'm not really going to talk about that today. Well, I will talk about bilingualism. But not so much about spelling or reading, which is indeed, what I do most of my work on. As you may know, in bilingualism, in Bangor, we do quite a lot of bilingualism research. There's a big research center called the Bilingualism Research Center, and I'm the current director of this center. So if anybody is also interested in collaborative work on bilingualism, I might be the person to talk to. So perhaps before I start actually presenting some data, we're going to have to ask ourselves, what is bilingualism anyway? I think we all have some intuitive, or it seems like a fairly obvious thing, but then when you start asking yourself, precisely, what is it? Is it knowing two languages? What's knowing? And so on, How many in there would consider themselves bilingual? Okay, usually 2 people, me, 3. Okay, and why do you consider yourself bilingual? Because you're more or less at ease in more than one language, I suppose, or? Most of you have done another language at some point, I would think. Okay, but you wouldn't go out and have a conversation, a normal conversation. So I guess there's a variety of definition, and some are more formalized than others. For example, in research studies, you might want to actually measure the level of performance, in people in several languages before they sign up for your study. But there is a more relaxed definition, which is that people are proficient, can hold a normal conversation in more than one language, and tend to use it on a regular basis, also that it's still active, current knowledge. This being said, there are a number of factors that are likely to be of importance when you study bilingualism, and particularly when you decide what selection criteria you're gonna have for a particular study. How you go more precisely select your participants just on the basis of the general definition I've given you, or you're going to want to be a little bit more specific. I'm going to just briefly mention a few factors, and just to give you a bit of an idea overall that all these things matter, but right now the whole research area is still pretty much in its infancy, particularly with regard to the neural representation. And it isn't the case yet that we have an answer at all to how these various factors affect bilingualism and language representation. There is certainly some evidence that all of these things matter, but right now the state of the art is that some studies have used one type of bilinguals and another study has used a bit of another type of bilingual, so it's still real difficult to get an overview. So age of acquisition, that means, well, you know, are they early bilingual? So, for example, you know, my children have been exposed to English and French from birth, from before birth actually. Whereas, you know, I started doing English in beginning secondary school, and a lot of people in Wales actually start mostly with Welsh, but then within the first 6 years of life get exposed to a lot of English and speak English. So there is evidence that all of these things matter. And mode of acquisition, so that is, that means more naturalistic versus formal, like in the context of language. Okay, so and you know that often age of acquisition and mode of acquisition can be conflated, because typically second language learners learn in a more explicit way than native learners. Then of course there's proficiency, so that is how good people are in each language, and is it equivalent, or is there one language that's clearly dominant? Another thing that can be important in studies is exposure, and exposure, the degree of exposure at different points in life. That becomes particularly important probably when you work with more older participants, and phasic stroke participants tend to be older because they may have been perfectly bilingual or really dominant in one language in their young years, but then have changed. The language dominance can sometimes change due to a new job, a change of country, marriage, into a family with a different language and all that, and it's not exactly clear what the degree of exposure is most important and what are the most predictive factors. Another factor that's likely to be of importance is the similarity between the two languages that that person speaks or reads. So, for example, languages such as Spanish and Italian are very similar in a number of ways, in terms of their sound structure, in terms of their grammar, in terms of how the system is written. So one might think there might be more overlap in the brain structures that are being used to sustain the two languages. Whereas, you know, in contrast to something like, say, you know, English and Chinese, which of course have some similar, all languages share some basic representations, but there are things that are quite unique to Chinese, the tone system, for example, and things that are more unique to English. Skip the last one for now. So today, I'm not going to analyze each of these things. I wish perhaps one day, you know, we'll have sufficiently progressed in my research program that I can actually give you, you know, an answer to exactly how these different factors affect the representation of language. I just want you to keep them in mind, and certainly one thing I'm going to try to do, one thing that will that I'm doing in my research program is that use converging source of evidence to understand bilingual language processing, and because of where we work in Wales, we're able to actually have access to a relatively large pool of participants who are at least quite homogeneous in the type of bilinguals that they are. Okay? So, okay, we can study all the factors, but at least we can do quite a lot of study, at least holding the participant factor and type of bilingualism factor constant, and then trying to ask that question. So as you will see, I mean, what's common in North Wales, especially in the part of North Wales where we live, which is quite, quite Welsh speaking, is that we have balanced bilinguals, very proficient in the two languages since childhood, and people don't tend to move too much, so then they tend to have, you know, relatively similar and pretty much daily use of Welsh and English throughout their lives. And so the type of data I'm going to present today, some is going to come from cognitive neuropsychology and some from brain imaging. Okay, so I don't know how many, I didn't quite know how many were neuroscience and how many were general, so I'm just going to give a little bit both, huh? Yeah, okay. So what do I call, there I'm going to use cognitive neuropsychology as a method to study the representation of language in bilingual people. And so the idea is that patterns of, so cognitive neuropsychology, I'm going to look at cases of people who have aphasia. That is, oh sorry, I shouldn't walk like that, huh? I completely forgot. Sorry. Am I supposed to stay like this? That's not going to work.
As much as you like.
My brain is directly connected to my legs. So. So aphasia, so that's people who have language disorders, language deficit that is due to damage to their brain. It could be any kind of damage. The most common right now is stroke, also with the aging population. And so the idea is that by studying this type of participants, you might get a window into the processing, the functioning of the normal system as well. A little bit, if you want to take an analogy, like, you may have no idea about how the car engine works, but when there is one piece missing, suddenly you realize, how important that particular piece was. And a lot of things in life gets learned by things breaking down, when the things are working perfectly fine and smoothly, you're usually not aware of the subcomponents and things that are involved in the act. And language is one of these skills that is extremely highly automatized, and it's not really the inner processes don't really lend themselves very well to introspection, so not reliably. Okay, so the first question I'm going to there's no clock, huh? Will you tell me when there's about 10 minutes left or something? Huh? I have a phone.
I've got, it's 20 past now, I'll tell you when it's
Okay, and I have until?
We've got until 5 o'clock if you need it.
Okay, that's the question. Okay, so just to illustrate that, this is some recent data, fresh out of the oven, where we've been looking at one particular question that has to do with the cognitive models of bilingual language representation. So let me first explain what we were looking at. So here what you have is two models of bilingual word production, just producing single words. In some ways they're extremely similar, so I'll tell you. So in both cases, okay, so you imagine you have a thought, your input would be a thought or a picture, you're going to say the word. So first you have to access semantics in order, because you want to activate a concept, a meaning for the thing that you want, the word you want to produce. And then if you're bilingual, after that stage, you need to pick the word form, and then you have to choose which language you want to say it into. Okay. So say in French, you might say, if you're French bilingual, you might think of a dog. Yeah, that's the thing first. It's not language specific. That thing that barks and has 4 legs usually, and so on. Then you would have to pick dog or chien, say, if you are. Okay, so everybody agrees more or less on that now. So meanings shared between languages, but then obviously the word forms have to be somehow distinct, not necessarily completely separate, but somehow distinct. Now, the question, so if you're in a picture naming task, you would go that way or that way, and you notice it's the same thing in that system here. Okay. The question is, what if I tell you chien, and I ask you, okay, just say it in the other language, okay? What happens then? And there's disagreement in the literature about how this may happen. Some people say, well, it doesn't really make any difference. So you're going to hear the word in the first language, and then it's going to take you to its meaning, and then you're back into the kind of picture naming situation. You have the meaning, and then you're going to find the other word. No difference. The alternative hypothesis is there are actually direct connections between the word forms in the two languages, which means that when you're translating, you could actually do it at least partly bypassing the meaning, or certainly with less reliance on meaning, on accessing the meanings, than than in this model. Do you see what I mean? Yeah, so you could have something, a direct link to between dog and chien. Okay. Okay, and so we're going to try to use data from brain damage, to see, to try to address this question. So the group of participants in this study, there was 10 Welsh-English bilingual aphasic individuals who were all highly proficient speakers of Welsh and English. And as is typical, as I told you, of the local population, they are all native Welsh. Well, most of them are native Welsh. But they acquired English in early childhood, so before the age of 6. And all of them, the one thing they have quite a range of deficits outside of language, but what they all have is that they have difficulty naming pictures. They have word finding problems. As compared to normal age-match controls. And the key feature that they have, and I'm going to focus on that from now on, is that they make what's called semantic naming errors. A semantic naming error, this is when, say you present a picture of a tiger and the patient says lion. So it's not a random error, it's related in meaning, but it's not the target. Okay? Why am I interested in these semantic? Well, I think I'll come back with the prediction. Okay? Another thing that all these patients had in common is that their understanding was pretty good. So if you said tiger and give them a set of pictures and say, okay, which one corresponds to the word, they could do that really well. So in all cases, the main deficits seem really in accessing the lexical, the word form representation. Okay. So these patients were asked to complete a number of tasks, including picture naming and translation in Welsh and English. And the two tasks, the picture naming and the translation, used the same words, the same items. So they're perfectly controlled from that point of view. In terms of matching the Welsh and the English, so there was a set of 80 items in each task, and they were matched across language for frequency, word length, and the number of cognates. I'm not really going to talk so much about the cognates in this talk. So naming task, participant is shown a picture on the computer screen, and we're asked to name it as quickly and as accurately as possible. Translation task, the words were pre-recorded by a native speaker, so say the person would actually it was the same person who was either speaking in Welsh or in English, and with a local accent. And they heard the word and they were asked to translate as quickly and as accurately as possible. So they're the same words. The only thing that changes then is the input, whether it was from a picture or whether it was from a word that they've heard in the other language. Is that okay? By the way, I didn't say, but feel free to interrupt if you need me to clarify anything. Okay, so what are the predictions? The predictions are distinct for these two. Okay, so the reason why we're interested in semantic errors, you'll see that, is because when a patient produces a semantic error, such as tiger lion, you know two things. You know, one, they're having difficulty accessing the word. So you know there is something that's been happening in accessing this level here. And you know, two, that there is a direct influence of that level here, because the errors are not random, they're triggered by semantics. It is the fact that you're thinking about the concepts that makes you go from tiger to lion, not from tiger to table, say, maybe something that's just form related. So according to this, if someone has difficulty here, they should make semantic errors in this same proportion in translation and in naming, yeah? Because I told you in translation you go that way, so it's basically a variant of a naming task. Here there are different predictions. You expect fewer semantic errors in translation, and that's because if I say chien, you could access you could use the direct non-semantic link. So you could use the just form-related associations between the two words. You might have still difficulty, there might still be problem, like if the word is completely unavailable from there, you'll have problems either way, but then you're less likely to make a semantic error here. You might make a form-related error, or you might make a no response, or something like that. Okay, so that's what we looked at. So what you have here is first just the performance in the two tasks. So there we're not looking at semantic errors, we're just looking at overall performance. Oops, I missed some of my scale. This is a, well, this is 100%, no, this is 80%. So this is just a group pattern, so you can see the patients are impaired both in naming in the two languages and in translation. If anything, they are a bit more in Welsh, even though they are actually, if anything, a bit more Welsh than English. After their damage, have more difficulty in the Welsh than in the English as a group. But they have difficulties in the two languages and in the two tasks, but they're nowhere near ceiling or floor in the two. Okay, so what we were interested in is the semantic errors. So what you have on the left here is the proportion of semantic errors, the percentage of semantic errors out of the total number of errors produced in English here and in Welsh. Never mind about the three columns, I'm not going to go into this, okay? So what you do see is they produce a fair amount of semantic errors in picture naming, okay? A little bit more in English than in Welsh, but certainly in both. And then what happens here when we look at translation, well, I think it's obvious. Obviously, we did some statistics, but you know, it's a little superfluous. You can see that there are far fewer semantic errors in the translation task than in the naming task. Yeah? And this is the same thing, but this time we're looking at it at the patterns in individuals. This time we've collapsed Welsh and English. But certainly what you can see is that in most patients, like this, the most striking is this one here, LM, you know, most patients produce a lot more semantic errors in the naming task, so the one that has to go via semantic system, than in translation task, the one which in theory doesn't have to go to the semantic system. And the effect is significant in 7 or 8 out of the 10. And there's one participant here, another one here. Well, these three are not so clear, but they're also the ones that produce hardly any semantic errors, even in naming. So perhaps, you know, they should have been there to start with. Okay, so just to conclude on this part, this data actually then seems to support that model over this one. Because one way to explain that the patients don't produce semantic errors so much in, you know, it's not all or none, they do produce some. So I'm not saying there's absolutely no semantic influence when you do translation. You know, actually in a lot of cases it would make sense, like if you're a simultaneous translator, you might want to know a little bit what you're talking about, and you would need actually access to meaning. For example, sometimes there could be more than one word, there could be two words that correspond to one word in the other language, and vice versa, because words have more than one meaning, and sometimes the other language has different words for the two meanings, you know. So I'm not saying, you know, that semantics is absolutely not involved in translation, but we do have some evidence that there is certainly a very strong contribution of direct links as well, so that you can block the production of semantic errors is blocked in translation as opposed to naming. Yeah? Okay, so now I'm going to change, and now I'm going to talk about the brain a little bit more. So where are different languages represented in the multilingual brain? So the early views, and you know, I'm talking actually pretty much until the 80s, 90s even. So the early view was that there probably when people had more than one language, they were probably not quite localized in the same part of the brain. Yeah, so you all know that there are parts of the brain of the left hemisphere that are considered to be language area, the language zone. Okay, and so the idea was that perhaps when people had two languages, the second language was not in the same place as the first. Some people, there are variants, so the quotation I gave you here from 1867 has to do with Broca's area, and so he said that maybe Brocan area was the language organ, as they called it, as Broca had coined at the time. So that it was the language organ only for the native language, and that the rest of the inferior frontal gyrus was used for the other languages. And there've been several variants, including giving more importance to the right hemisphere for second languages and things like that. And so, where did these notions come from? Well, first, it seemed to make sense, and one think, especially if you're thinking in that case, they were mostly thinking really in terms of second language, rather. So this kind of bilingualism, So you might think, okay, you're born, and they're quite Linnaeus views also. So you're born with a certain structure for language. You've already filled it up, so to speak, with your first language. So then you're going to have to find other neural tissue to put so that you can see that there is a certain logic in that. But another reason is these people were all working with aphasic patients, neurologists. At the time there was no imaging, there was nothing, and one of the only source of information you had about what was going on in the brain was by looking at brain damage. And one thing, that has been noticed pretty early on is that sometimes when people had brain damage and they were previously proficient in more than one language, sometimes the brain damage didn't really have the same effect in the two languages. And so there's been a number of patterns of dissociations reported, quite a range actually, giving some references here. So for example, there could be cases where after the stroke one language seems to be quite normal and the other one is very impaired, or both impaired but one a lot more than the other, and pretty much every kind of combination that you can think of was seen at one point or another in different patients, including the pattern where there was a patient who could only speak one language one day, and then another day it was the other language, and so on. Okay, so quite interesting. And so, you can see, what did people conclude from that? So, well, makes sense, at least perhaps not the last one, but at least the one where one language is affected and not the other. You say, well, that's normal. They're not in the same part of the brain, and so the lesion has affected the part of the brain that represents one language and not the other. So fine. So that went on like that, but then, and I'll come to that, it's actually, people started having doubts for a number of reasons. First, actually these cases are nice. They're exciting. They made you, when I told you about the case of, one language is here one day and not the other, everybody finds it exciting, and so people say, I'll publish that case. It's a nice one, And, when this is the one, the run-of-the-mill patient, oh, look at that patient. He's aphasic, he has two languages and they're both impaired, and somehow doesn't do the same thing, So what happened is because they were neurologists and they were mostly publishing single cases, the only things that ever got published were the sexy dissociations, and not actually what's the typical pattern. And the typical pattern, I'm afraid to say, is that pretty much the same thing happens in the two languages, actually in a very interesting way. I don't think it's boring at all, personally, to observe the degrees of similarity between the two languages. So then you have to start thinking, okay, well, can I find an explanation, that's consistent with the two types of patterns? Obviously, if everybody had huge lesions, the two languages would also be impaired, but that cannot be the explanation. And then there was also the beginning of neuroimaging that led. So when people started looking at what's happening, and I'll come to that, what's lighting up, if you want, in the brain of neurologically healthy people when they do task in more than one language, they didn't see, that there were clearly different brain areas activated. But okay, so let me tell you a little bit more about what I mean when I say the deficits are quite similar in the two languages. So here again, Welsh-English bilingual. So this is a different series of patients. This data is published. And so in this study, we had 7 stroke patients. Pretty much the same characteristics as I've told you before. And what they had, so in that case, we were looking at their reading aloud. Actually, the goal of the study was, I'm using it to illustrate the degree of similarity, but there was a whole thing about orthographic transparency and different reading systems that I'm not really going to get into in that talk, but I'm happy to answer questions about it. So what all these patients we knew, we selected them this time not for semantic errors, we wanted them to have difficulty reading non-words or pseudo-words, so new words that you can't have learned, such as zap or crappy stock and things like that. Okay. Doesn't mean anything, does it?
Sure, so.
Okay. I try not to improvise too much, so I have on occasions said things that were not really non-words and I didn't know it. Yes, so they all had difficulty, and then we wanted to say, okay, so what are they doing? In what way are they similar in other ways? And so these are the results. So this is the participants' accuracy in reading word lists in English and Welsh. And so half of the stimuli were these made-up words, and half of the stimuli were real words. So what you have in the solid columns is the real words, and what you have in the dotted columns is the pseudo words. And it's for the two languages. And basically what I want you to notice here is that irrespective of the overall degree of severity, so here my patients are ranked as a function of how bad they are in the task. Okay? But what you notice is that they're all better for real words than pseudo words. Okay? Fine, it's not a common pattern, but also to this, and in some cases massively so. So that's definitely nothing even remotely normal in something like that. But what's interesting is that it's exactly the same, well, statistically exactly the same in Welsh and in English. Okay, so when you compare, it's not just that they have difficulty reading in Welsh and in English. Like if they have this massive dissociation between words and non-words in English, they have the same massive dissociation between words and non-words in Welsh. Okay, so it's to that level of detail. We also look at another factor that affected the performance of 3, it's now 4 of the patients, which is word concreteness. Okay, so we're still in a reading task, but even though it's just reading, there are patients who are much better at reading concrete words such as table, dog, things that you can.
I spent ages doing that.
Is it 4:40? Okay, sorry. I was trying to see, do I have 4 minutes? 4 minutes, 40 seconds? No, okay. That's okay. Okay, so I have to hurry up a little bit. I have 10 minutes for that, yeah?
Yeah.
Okay. And so they were, so I was saying patients who are better at concrete words than abstract words, such as truth and love. So they're not less frequent, but they're just more abstract. And here again, what's interesting is that when you compare, the patients who have that effect in one language also show it in the other language to the same degree of significance. Okay, so the things are just, I'm going to skip that. Are just, basically every single dimension but there's been lots of patients who've been shown to have very similar performance when they have after stroke in their two languages, and not just in terms of overall performance, but also in terms of which specific factors affect performance. And notice that this differ between patients. It's not like every patient has a concreteness effect. It's not like every patient, There's actually quite a lot of difference within the group, but when they have an effect in one language, they tend to have it in the other. So that certainly suggests, actually a lot of similarity in the neural instantiation of the two languages. contrary to what the initial cases of aphasia were suggesting. Okay, this is just another example with nouns and verbs. Okay, and as I highlighted very briefly, since then people have started putting people in the scanner and looking, okay, which area of the brain lights up when they're doing one language or another. And to make a long story short, you can't really distinguish brain areas, at least in proficient, balanced bilingual, when they speak one language and when they speak another or recognize and so on. I mean, typically they don't speak much in the scanner, it must be said, but when they process one language or another, it's the same brain areas that respond. And when you do observe a part of the brain that responds to the contrast between one language and the other, it tends to be mostly in kind of frontal, prefrontal region, and it seems to be more of an index of the relative difficulty. So brain areas that are more related to effort, to task difficulty, to strategy, so to monitoring, rather than language areas per se. So effortfulness, that's what I'm saying here. Okay? And actually, ever since, this study has started, it's been basically a series of null results mostly, in terms of finding that. What has been most interesting is actually there's been more information has been revealed about the language control networks than about language representation. So this is, I'm going to go a little bit quicker. 10 minutes, I think I'm going to, well, I had 10 minutes. I have 10 minutes? Okay. So the idea here, just very briefly, is you have to okay. When you're speaking one language, for that matter, or two, now there are parts of the brain that actually encode the linguistic knowledge itself. So how how do you call that thing that barks and so on, okay, dog, kind of abstract thing, and you up all the way to how will I move my mouth and my tongue to actually say that word. I mean, all of this has to be, there is a memory of that. You don't recreate it, well, some things you might partly recreate, but it has to be encoded. But then you need to have general control systems that actually tell you and monitor and regulate how you activate these areas. And these, you can imagine, are particularly important. Oh, sorry, I'm out of the camera again. This is a torture. You're going to need to time me. Sorry again, if anybody ever looks. So when someone is bilingual, they certainly need to monitor their language, for one thing, because you don't want to have to keep on going from one language to another, particularly when you're talking to someone who doesn't understand the other language. Yeah. So there has to be a lot of regulation of relative activation, inhibition, suppression, all kinds of things that are going on in normal, even in monolinguals, but even more so in bilinguals. And so, they've proposed a network of area which are actually largely outside of the language network itself, but that interact with the language network to regulate and help with the bilingualism, the constraint of the bilingualism system. Okay, and there's a lot of evidence that now supports this, and some of it comes from neuropsychology too. So for example, there are cases of people who have pathological language switching or mixing. It's pathological. Most bilinguals do that, do cross-code, especially if they're talking to another bilingual. It's pathological when actually the person, it's going to break down communication, and when it can't be avoided, and the patient has no control on it. Okay, and I'm just going to give you a quick example because I want to get to my fMRI study. So this is, for example, a patient who was trilingual. The patient is tested in Italian and has been told, okay, now you speak only Italian. I don't understand, these other languages that you speak in English and Armenian, and the patient trying her her best, say, I cannot comunicare con you, or gee, I cannot say il mio nome to you, I am a disaster today. And this patient had a lesion in a subcortical structure that is part of the control system that was proposed by Abutaleli and Green initially, okay? So it's not so much a language problem, it's a language control problem. And I think the idea is that you could probably explain a lot of the initial cases of aphasia where the deficit was quite selective by thinking actually these people were not really aphasic in the traditional sense. They didn't have damage to their language, they had damage to the control system. So for example, you can imagine that damage to the control system may lead to a language to be unduly suppressed by the dominant language, for example, at least some time after the damage. Okay, so still, it would be nice to have a bit more evidence. It's still, at the end of the day, okay, fMRI tells you, suggests that the two languages, they're in overlapping areas, yeah? Because when you look, in normal fMRI, you look which areas are activated when I speak English, what areas are activated when I speak English, but they're the same areas, You can't distinguish them with the traditional methods of analysis. And so, okay, but we'd like to learn a bit more because clearly there has to be something different about the networks, because the language identity has to be coded. The brain needs to have some way of knowing where and how to go pick a word from the right language and not from the wrong language, even if they're more or less the group of words in the same part of the brain. So what we started thinking is that probably the traditional way of analyzing fMRI data was not particularly well suited. It gives you globally, it gives you micro-anatomical information about which regions are activated, but it doesn't really allow you to go see within regions if there are some networks. And I'm looking at Raf here, this is, the analysis were done by James, okay, so don't ask me too many technical details here. Okay. So what we tried is to use a multivariate analysis to uncover language-specific neural network. So in a nutshell, univariate, that's probably what most of you have heard about, okay? So you measure, you put someone in the scanner and then you look at how much a particular region or voxel is activated in one condition, and then you look how much that same voxel or region is activated in another condition, and then you compare them. Okay, so when we do that, with bilingualism, if they were much, you compare them, you see nothing. They're the same thing, okay? But with multivariate, you can go and look at more fine-grained patterns that are associated with processing a particular stimulus dimension. And in that case, the one we're interested in is bilingualism. So we had 11 students this time. And they were Welsh-English bilingual, proficient since before age 6, still same time of population, school bilingually, and use both spoken and written Welsh on a frequent basis. And the task in this case was a semantic decision, so people were presented in the scanner with written words on the little screen. And they had to say whether it was a natural object, such as a dog, or a man-made object, such as stable. So they had to press a button. And in some cases, the words were in Welsh. In some cases, the words were in English. Okay, so it was half man-made, but this, this man-made, non-man-made is not the dimension we're going to analyze. It's just to give a task to do to the participant. What we're interested in is whether the words are in English or in Welsh. And then we had a control condition, which was high frequency, low frequency. And I'm going to have to skip a little bit on the frequency, but I'll answer during the questions. So the words were presented in blocks of 7 items. And first they had a little flag that told them whether they were supposed to process them in, whether they were about to see a Welsh block or English block. So a language cue. Okay, and so what we did is we looked first with the traditional technique of analysis, GLM, and then we're going to look with the multivariate technique. So when we did the GLM, we pretty much replicated what other people have shown before, which is pretty much nothing, okay? So when we compare, the activations of the two languages, we pretty much get the same thing. That's why, this is so empty, and then we get some borderline significance in a few spots that are quite small and are pretty much outside the normal language areas. Okay? Frequency, we have something that's what, we just replicate normal findings also for that. But when we looked at, with the multivariate, here is what we see. What we see is much more interesting. In that case, we see an extensive network of brain regions which are sensitive, which seems to be sensitive to encode language identity. And in that case, most of these regions are mostly in the traditional language areas. Okay? So it's almost as if we're looking in the lexical semantic system, we're looking at those parts of the brain that are involved in recognizing written words and accessing their meaning, because the task, natural man-made forces you to process the meaning. And with this technique, we're able to see areas where it seems to be, where there is networks that overlap for English and Welsh. They're at the same place, but you can, with proper multivariate techniques, see patterns of autocorrelations within one language or the other. And I'm just going to go to that one very quickly. And I told you, we had frequency as a control condition, just to relate whether it was just about effortfulness or something like that, even though we picked participants who were very good and as balanced as we could, you never know. And I think so what this is showing, this is the multivariate results and the frequency altogether. And so what you can see is, okay, there are areas that respond that perhaps are more related to difficulty somehow, so they respond in the same way to language identity and to word frequency, so how common or uncommon. But there are certainly areas, and they are in areas which are very well considered to be lexicosemantic areas. There are areas that just are sensitive to the language status and not to word frequency. And these are all the ones in orange here. You have a little bit of that, and here also, which is pretty much a part of Broca's area here. Yeah? Okay, and this is a very busy slide, but just to tell you quickly that we did some follow-up analysis that really showed us, so we basically looked for each language area that we had identified as a significant area in using one form, the GLM analysis, or the other one. Okay, so we looked for that area. So that area that came out significant in one analysis, what did it look like in the other? So it could be that it's a question of threshold, and actually the two analyses pretty much give you the same information, but it's just some slight difference of threshold. And I'll just give you an example here. I mean, it seems pretty clear that the two methods really measure some different things. So for example, here you have, this is a region that was activated that showed a strong sensitivity to language dimension according to one in the GLM, and it doesn't show up anything in the multivariate. On the other hand, this is an area this is an area that the multivariate technique tells you encodes language, and it doesn't show anything in the other technique. So the idea is the two techniques are really measuring different things, and that in terms of looking at the inner micro-organization of the bilingual system, it looks like the multivariate techniques are much more promising than the way that it's been done before, which turns out teaching us a lot about the control systems, but very little about the way that language itself is represented in the bilingual brain. And it was reassuring to see that we see with the new technique, we observe the effects that sensitive to language where we should be seeing them, which is in areas of the brain that are thought to encode lexical-semantic information, and not say in the occipital cortex, and there might be a big bias in the way that our words look, for example, you have, or, in completely prefrontal or things like that, we might want to reconsider our interpretation. Okay, so I'm going to leave it here, and just to thank all my collaborators on the projects I've presented today, and also the funder, mostly the SRC and MRC. Thank you.
Okay, does anyone have any questions for Marie-Josephe?
Your MRI study, do you have many blocks where one language is followed by the other languages? You have blocks where one language is followed by itself. So that's controlled for me. What happens in terms of regions of interest when you have sustained use of a language, whether you start to see a less of a distinction of those regions that are activated specifically by a particular language. Presumably language switching studies will tell you something about this.
That's right, so that's one of the things. I mean, because I think sometimes some of the things we see, including in the GLM, more anteriorly, might have to do with the fact that there is a language switching element in the task. We have to make, because an alternative would be to do one session just in English and one session just in Welsh. There's pros and cons. I guess that's the next experiment we should do and see if we find the same results. At the time, well, we were kind of there, but then they'll move, and the head position won't be exactly the same. And what if someone tells us it's because of that? We're not finding the same thing. So we started with that, but at least it was a pseudo-random order of blocks, and there is there is a switching element, but there's also, not always. I mean, there are periods of rest, but not in between each block. Yeah.
We've got time for one more quick question before we get to
So I was just going to ask about direct links between the lexical items in both languages, and if you had any idea about how that develops, because it would seem that in a system in which you're trying to control differentiation of language, that to connect them would seem to be counterproductive.
Did you hear the question? I'll repeat it while I think about the answer. She said, did you have any idea about how, coming back to the first half of the talk about the direct links in translation, asking, well, it's a little bit counterproductive if what you want is to keep the two languages as separate as possible. Certainly there is some evidence that these direct links are even more important in people who actually learn as a second language than others, because often, people who are second language learners ask, how do you say that, in the other language, and then you can see, that direct connection. It's probably, actually the reasons why it was questioned was more for the type of bilinguals I study, where actually I agree, you see less of a motivation for it, On the other hand, it's the same thing with reading. If you look at Welsh reading, there is no motivation for, learning the whole word at the whole word level in Welsh, because it's so transparent. You don't need it. My view of the brain more and more is it processes things, and it processes patterns of association, and whether you need it or not, when things, are learned or are co-activated, they end up creating relations together, and I don't think that these things are necessarily fully determined by necessity, but just more than by the fact. There is certainly a lot of evidence that people co-activate their languages. So I don't know if there is. Well, first, there's one thing is you never know. A lot of people actually really live in bilingual things, and you never know when you might have to quickly switch from one language to another. It kind of depends, but certainly it's the case in my home. I speak French to my children, mostly English to my husband, and and then when we're with family, it gets this kind of constant, okay. So you don't want to over-inhibit. And there's certainly a lot of experimental evidence that there is co-activation. So it's this always fine-tuning of co-activation and then just boosting the one of them at the right level to be functioning in the right language at that time. But, yeah.
Right, I'm sorry, I think that's all the time we've got for questions today. Just want to say thank you once more for a very interesting talk with Marie-Josephe.